to prove, in this case, that L and M are parallel. This is where we left off yesterday at the end of class, and is the second type of proof that we'll do. So we saw yesterday that we might be told, I'm going to show you an example real quick, that we might be told that some of the lines are parallel and then use those properties to prove other things, like some certain angles are supplementary or parallel or whatever. So like this one, let's see, excuse me. Actually, if you look on your packets, the first two proofs were that way. We were told that some lines are parallel and asked to prove two random angles are congruent in that case. And then in number 2, told some lines are parallel, asked to prove 2 are supplementary. So that's kind of one type. And then we saw in number 3 on the packet, as well as our warm-up, that we've shifted gears and now we're being asked to prove that lines are parallel. So it's similar structure, but different approach a little bit. In the warm-up, we're told that 1 and 2 are congruent. So remember, we want to add that to our given. And that's not the writer. Angle 1 congruent to angle 2. That was given. Note that it's not in our picture, though. And so the more information that we can put in there, the better. So I would go mark that angles 1 and 2 are congruent. Just helps visualize what's going on. All right. What kind of angles are those if the lines are congruent or parallel? Yeah, they're alternate exterior. So we had to be told that they were congruent in this case because we don't know that lines L and M are parallel. We can't assume that just because they look it. We're not told that, so we can't use it. Everybody clear on what I mean by that? Okay. That 3 is sitting there, which is a little conspicuous. Let's go ahead and bring it in. What kind of angles are 1 and 2? 1 and 3, excuse me. They're vertical. So angles 1 and 3 are congruent because of vertical angles. Okay, and we'll add a congruent mark to that. Now we have, in our picture, it shows that 3 and 2 are congruent. We haven't stated that in the proof yet. So let's go ahead and add that in here. Angle 3 is congruent to angle 2. And that's because I can just substitute 2 in here for angle 1. Since angle 1 and 2 are the same. We'll just substitute it in there. Okay. So 3 and 2 are now stated in our proof to be congruent. Well, what good did that do? Like, we weren't asked to prove they were congruent, so why did we? Well, let me remind you, if you pull out your reference sheet and look at the bottom of it, the only way to prove that 2 lines are parallel is one of these 5 at the bottom. That's the only ways to do it. And we have to show, kind of going to highlight this middle section. We have to show that one of these are true first. So if corresponding angles are congruent, we have to show that's true a different way, what I call the backdoor way. If same side interior angles are supplementary, etc. We have to show that one of these is true, then the lines are parallel. Every one of those ends with that phrase. But we can't use parallel lines to show it. That's not okay. That's like using evidence to prove itself, which doesn't work. So, did we meet any of these? Well, we were given that one. So I suppose we could have jumped right to that, but we met this first one by proving that angle 3 and angle 2 are congruent now, okay? So if we go back and look at that, angle 3 and angle 2 are corresponding angles, and we have proven that they're congruent using the back door. We didn't say because they're alternate, or excuse me, because they're corresponding. None of our reasons said that. We have a given that connects two of them, and then vertical angles that brings in the third. And that's why. Okay? So at this point, we have now met the condition to use the converse. It says if these two angles are congruent, then the lines must be parallel. That's what our condition says in one of those bottom reasons. So we can now say L is parallel to M because of, and you have to say this word, converse of. If you don't say converse, you're using the theorem backwards, like you're using it the wrong direction for this. So converse of corresponding angles theorem. So abbreviating a little bit there. Again, if all you just say is corresponding angles, you're using the theorem the wrong direction for this application. So we have to say converse. Converse is the one that says if those angles are congruent, then the lines must be parallel. Questions on that? Okay, grab your packet. Let's apply that same logic to number 3 and go ahead and finish that one up. So you can see number 3 is the same goal. We're trying to prove two lines are parallel. And yesterday we wrote, don't assume they're parallel until proven. So don't use any parallel angle theorems for those lines. We can use them in this case for G and H, because G and H were told to be parallel. And you can see that notation down here in the bottom right. Those ones have the parallel notation. P and R do not. So do not use anything on P and R that's parallel. So we've got our given. Easy step there. Angle 1 and 3 are congruent. Why? What kind of angles are angles 1 and 3? Yeah, if we ignore this entire bottom part of our figure, we see G and H are parallel, P is a transversal, and that sets up 1 and 3 to be corresponding angles. So we'll say corresponding angles theorem. We don't need to use the converse because we're not using it in that direction. Okay, angle 2 and 3. Why are those congruent? Nope. Yeah, they are not corresponding angles because, well, they are, but they're not congruent because of that, because P and R have not been proven parallel. Does everybody see what I mean by that now? So Parker said corresponding, which is, that's the type of angle they are. But they are not congruent because of that until we prove P and R are parallel. But here's what we just did. This is what Eva said. So we want to substitute this 2 right there for the 1. And now we have 2 and 3 are congruent through the back door. Meaning we've done it a different method. We haven't relied on the lines being parallel. Okay. All right, with 2 and 3 being congruent, so now I'm going to go ahead and mark those. Parker's right, these are corresponding, but to prove those lines are parallel, what word do we need to write first? Yeah, say it. Converse. Right? We're going backwards. We're saying if those angles are congruent, then the lines are parallel. So converse of corresponding angles theorem. Now we know for sure those two lines are parallel. Let me just read that to you or show you. If corresponding angles are congruent, that's what we just proved, then the lines are parallel. That is the converse of CAT, corresponding angles theorem. Just abbreviate that. If you want to write CAT on your proofs, that's fine. That's not it. Okay. So that's a parallel line proof. You can see the slight difference to the first 2 that we did yesterday. All right. Any of the homework proofs, so it was 4, 5, 6, 7, 8. And I'll show you the answers in a second, but any of those you'd like me to do and talk through before I just show you them? All right, let's do 7 and 8. 7, remember this black mark means that it's parallel. Probably a good idea to go mark that in your figure just so it registers with your brain that those are parallel. So we are asked to prove that angle 2 plus angle 7 is 180. In other words, that they're supplementary. Let's start with our given. So I've written my given and it's in the picture. I've put the information in there. So we've got to figure out a way to connect 2 and 7. What kind of angles are they in terms of just a name? Yeah, good job. Same side exterior. So this is going to be a short one. Here's what they actually say. Angle 2 and angle 7 are supplementary. That is the same side exterior angles postulate. Back just for a moment on your reference sheet. I want to point out where we are on there. We are making connections between two things if two lines are parallel. Yes, we were told that. So it's fine. We can use any of those. So we picked number 1 on here, same side, number 2, exterior angles postulate, which is okay to abbreviate SSEAP. I will know what you mean by that if you don't want to write it all out. Just make sure you know what it means and you don't use the wrong one. So if I had you write this, you have to know this first to use these. Well, we do. We were told that the lines were parallel. Okay, so we wrote SSEAP. SSEAP is why those two are supplementary. Now, is that geometry language or algebra? That's geometry, right? That's like a verbal description. And look at the thing we're asked to prove is algebra. So how do we switch? Definition. Perfect, good job, Parker. Okay, so switch from geometry to algebra using a definition. So now we can say measure of angle 2 plus measure of angle 7. And that is the definition of supplementary angles. Okay, just back to our reference to show you where I was looking. Switch between measures and angle relationships like congruence or supplementary. Algebra to geometry are back. So we just used number 1, 2, 3. We just used number 4, definition of supplementary angles. Okay, so that was a shorty. And then you said number 8, right? All right. So AB, and again, the parallel symbol is kind of weird on this sheet. But AB and EC are parallel, BC and EF also. And it's not marked, so we'll just go ahead and mark that. So everything is in our picture. The reason for that is given 1 point in the books. You should never miss that first line, right? That's like freebie points if you just copy the given and write the word given. Okay, we're asked to prove that 7 and 4 are congruent. So here's my question. Do 7 and 4 have a direct link? like the last proof that we just did, number 7, we had a direct link between those two angles. Do we have that in this case? No, because they are on different transversals. No matter how you look at this, they're on different transversals, so they do not have a direct link. So we've got to kind of work our way through making connections. On our reference, if two lines are parallel, yes, we actually have 2 sets of lines. So we have 4 lines that are involved. So we just need to go look if we have any of these. Like, do we have any of those that we could use to chain an argument from 7 to 4 or vice versa? Okay, so same sides, alternates, correspondings. So we need to start by bringing one of these in here. In other words, we've got to say something about 7 or 4 and then make connections to the other one. So which one do you want to start with? I'm saying which angle number? You want to bring 4 in first? Okay. Tell me what about 4? Like 4 and what? He said 5 and you said 5, so that sounds good. What kind of angles are 4 and 5? Angle 4 is congruent to angle 5 by alternate interior angles theorem. And if you look on your reference sheet, AIAT is an abbreviation for that one. So you don't have to write it all out. But again, you've got to know what that means. So go ahead and mark that in your picture. Angle 4 and angle 5 are now congruent. Okay, so we have 4 in our proof. Like in the words of our proof, 4 is taking part. So now we got to bring 7 in somehow. Where do you want to go next? Or what? Awesome. So angle 7 and angle 5 are congruent by the corresponding angles theorem. And you've seen that already as abbreviated as CAT. If you want. I think it's good to write it up. So I have 7 and now 5. So do you see how we have a chained argument, like a linked argument, 4 to 5 to 7? Anytime you set up that ladder or that chain from one to the next, what can we say at the end to prove what we're after? Substitution. So 7 and 4. And it's because of this. We just take this 4 and we stick it here for the 5. Since 4 is 5, plug it in for 5, and now we have 7 is 4. And that's just by substitution. All right, any others you'd like to do from that first set? Are you feeling better about these? Like, did they seem like they're going okay? Let me show you the others real quick. So number 4. I split the givens into 2 this time, that's a good thing to do. Angle 1 and 3 are corresponding. And so angle 5 and 3 by substitution. And note here, sometimes this is helpful to extend parallel lines. It helps your eyes maybe see it a little better. So you're welcome to do that if you need to. And then I just wrote the arrows to show that kind of linking of pieces. So 3 to 1, 1 to 5. That means I can go directly from 3 to 5. Okay, number 5, similar. It says angle 6 and 3 are supplementary. That was given. 2 and 3 are same side interior angles. So SSIAP, same side interior angles. I'm going to explain all the red over here in a second. And then 2 and 6, I put transitive property, which means if they're supplementary to the same thing, then they're equal to each other. Technically, we need to add all this red in for this to be what's the word? Like a super academic proof where we switch over to algebra and we do some of the subtraction stuff to get rid of an angle. Like here we set both equal to 180 and then them equal to each other because they both equal the same thing. And then we subtract off angle 3 so that 6 and 2 are congruent, and then switch over. That would be the best way to do the proof. We saw that yesterday in our warm-up. But I'm okay at this level and at this point with the blue also. Okay, number 6, little shorty here. Note here that I extended all the lines a little bit. It helps your brain process what you're seeing a little easier. So 2 givens, the lines are parallel, and 2 and 1 are congruent, which they have no reason to be. That was why we had to be told they are. Substitute. Well, let's say this purple line first. Angle 1 and 3 are alternate interior. Remember AI, alternate interior. And then just substitute for the last piece. So how'd those go? Those of you who did them all. I typically grade on these, I grade about 1 point per line or half point per blank. So like this would be, it probably wouldn't be 4 points because the given is all just really one line, but 3 points. So 1, 2, 3 points. How many did you get on that one? Okay. All right. I told you yesterday we were going to have a test tomorrow, but we are not. We're definitely not there. Here's the plan. We'll do that next week. So we'll use more time today to finish out 9, 10, 11. These parallel line proofs, see how those go. And then tomorrow we'll look at these, maybe do a couple more on the screen, and then start reviewing like all the angle solving, because that's actually a bigger part of this assessment is all the angle solving rather than proving. So I'm going to give you some time, just this last part of class. Go ahead and finish this packet. If you didn't get to all of them yesterday, please do them today. And then this will be homework if you don't finish in class. So please call me over. Let's check, make sure these are going well. Get the help that you need.